Hi, I'm Beck, and with my team, Kitty, Dushan, Ethan, Robert, and Daniel, we tackled the problem of cost estimation for public goods and services. We partnered with Paraguay's National Department for Public Contracting, or the DNCP for short. So the DNCP performs three main jobs. They are in charge of public purchasing at a national level, which means that they oversee and control spending of other public entities. These include your municipalities, your governmental departments, your universities, etc. Additionally, they maintain a registry of state-approved vendors, and they identify and inspect corruption that occurs during the public spending process. For this project, we focused on the DNCP's role in public spending or public procurement. For public purchases, these entities must go through an official process. When an entity wants to buy goods and/or services, they create a tender detailing what they want to buy. Approved vendors then offer the desired supplies along with a reference price of what they believe the supplies are worth. And if agreed, the entity inventor then sign a contract to make it official. So the DNCP spends billions of taxpayer money each year on the purchase of goods and services. Additionally, adequate prices for these items are often not clear, and this leads to public entities overpaying, resulting in a loss of taxpayer money. Prior to COVID-19, the vendors would provide a reference price, but never publish any information on the analysis or the reasoning behind how it was obtained, and this enabled overpricing. There is now regulation on the vendors to explain how they reach their reference prices. However, the DNCP wants to be ahead of the curve and calculate an adequate estimation of prices on their own to reduce public spending and avoid overbilling. Additionally, adequate knowledge of adequate prices would assist in identifying instances of corruption throughout this process. So the DNCP has historical data detailing all tenders, offers, and contracts for the past 11 years. In total, this represents about 3 million observations. These observations contain everything about a given purchase, with information as to who the buyer is, a description of the product in 5 different levels of granularity, and whether or not the contract is open. For the products themselves, there are over 60,000 unique goods and services. These range from cleaning chemicals to paving 50 kilometers of road to printing a piece of paper. And the prices between these items vary greatly as well. There are carrots that cost 50 cents, and there are bridges that cost $50 million. And as we discovered very quickly, this variability and large scope makes it difficult to accurately predict prices for everything all at once, which is something our partners at DNCP have struggled with in the past as well. So we started to change the scope of the problem we were solving. The challenge was no longer to develop a single model to predict the prices of all products, but rather it became to develop multiple models specializing in certain subsets of the data. And our goal was to keep these models generalizable and useful. So we split the data in multiple ways to serve this task. The biggest split was creating different models for goods and services. Furthermore, we identified that high-priced items, such as building a whole bridge, were negatively impacting our ability to predict lower-priced items. So we separated out these transactions. Similarly, we found that products under $2, such as a single piece of paper or a single carrot, make up more than 25% of the data. And these hindered our ability to predict these mid-range price items. So once again, we separated out these smaller priced items. Each narrowing of focus improved model performance. And in terms of data segmentation, there are still many avenues to pursue that the DNCP will further investigate. To support the DNCP and ourselves in the development of these compartmentalized models, we built a dynamic and automated data pipeline specifically for the DNCP's database. Through an easy-to-use configuration file, our pipeline performs a multitude of tasks. Using consumer price index information and conversion rates, all currencies are standardized and adjusted for inflation. Then, desired variables are transformed and desired filterings are applied, such as only selecting goods that are low-priced. Then, the dataset is enhanced through the creation of new groupings based on text analysis. Using information about the buyer and which items are frequently bought together, we establish groupings that help identify related products. With the dataset established, we then set up hyperparameter tuning and training for any desired algorithm or model. And finally, the model is used to predict new data and automatically generates evaluation metrics and figures. This framework enables fast and easy model building that is customizable to the DNCP's needs. Using this pipeline, the DNCP will be able to further investigate the refined models that we developed and go further to reach optimal price prediction models that are beneficial for both them and for Paraguay. Additionally, due to the dynamic nature of the pipeline, the DNCP can utilize it for projects beyond cost estimation, such as anomaly detection for identifying corruption. Thank you, and check out our poster for more details.